Okay, this video is for Tyler. It's on vertical projectile motion, question 3, because you missed the lesson, lad. The things we needed to know for vertical projectile motion was the 3 formulas. Vf is equal to Vi plus At. Vf squared is equal to Vi squared plus 2a change in y. And the third one is change in y is equal to Vit plus half At squared. Okay. In vertical projectile motion, we always have the a, and that a is a negative 9,8 meters per second minus 2. So we're always going to consider upwards as positive, right? Which is why acceleration, which is the force of gravity, always acts downwards. Okay. Say, and then there's a couple other tricks. So we always have the a in these formulas. So we have the a, we have the a, we have the a. And this change in y is displacement. So it's basically if an object was there at 20 meters high and then it gets down to 10 meters afterwards, its displacement was negative 10 meters if we're taking upwards as positive. You know what I mean? So it's gone down 10 meters. Okay. Yeah, where the fuck's the eraser? Okay, don't know. Yeah, and then some other tricks. Say we had an object here and it was projected upwards. So that's its position over time. It's going upwards. At this point here, at its max height, so at max height, max h, its velocity is equal to 0. So I want you to imagine if this was projected up at some v equals x, positive x, because it's going up, it's still got a positive velocity. It's going up, and then acceleration is acting on it. So negative 9,8 is always acting on it. So it's always slowing down. And then eventually it reaches this point and its velocity becomes 0. And then it starts making its way down. And now this time acceleration is like favoring it. So it starts speeding up, but downwards. And then there's this little trick that if it's projected at this height at a velocity of x, then on its way back down, at this point, when it returns to its original starting position, the original height of its starting position, its velocity at this point would be negative x. Okay, it's a nice little trick. So it helps us because if we have this vi, this initial velocity here, and we know that at this point up here, its Vf is 0, then we can go get that time, and then if we double that time, we'll know the time it takes to go all the way from here back to its original position. Okay, good stuff. I need to find the eraser. Okay, screw that. There it is, Okay. Now we're going to use all this information to go grind out this question. See what it says. It says a ball is thrown vertically upward from a height h, so the height h here, with a initial speed of 15 meters per second. And then it says at the same instant, this ball B is dropped, right? So it's dropped. And then another trick is, if they say it's dropped, you must know that its initial velocity, so ball B, its initial Vi is 0, because it was dropped, right? It's not projected downwards, it's just dropped. Whereas ball A, okay, so ball A is actually, they use the word thrown. Okay, so the word thrown means that it actually has a Vi, so its Vi is 15. Okay, so then, here, let's read the rest of the questions. So it says, 3.1, explain the term free fall. So free fall is when an object is only under the influence of the gravitational force. So the only force acting on it is the gravitational force. There's no air resistance. There's nothing else acting on it. So the only force, if we had to draw a free body diagram for all of these, for any ball that we're ever going to consider in projectile motion, it's going to be straight down, just Fg acting on it. Okay, and then yeah, that's it. So perfect. Calculate the time it takes for the ball to return to its starting point. So there's a couple ways we could do this. The first way is, okay, well, let's look at our formulas, right? So we know its initial velocity is 15. We know the VF at the top of its, at the top right here, its VF is 0. So if we go here and plug in 15, 0, and negative 9,8 t, we can calculate that t. And then this t, if we times that t by 2, we'll get the time it takes for it to return to its original position, right? In seconds. That's one way we could do it. Another way we could do it is if you look at another formula here. We'll look at this one. Actually, we can apply this the first formula in another way as well. We know that once ball A like goes all the way up and then returns to its starting position, we know the VI initially was 15, and then we know the VF at this point will be negative 15, right? And then if we go take those values now and plug in, we won't have to multiply it by 2, because we know VF, I fucked up here, lol, okay, this is obviously meant to be VI 15 and 0 for the first case, because what is happening is it was projected with an initial velocity of 15, and then at the max height it would be 0. Okay, but then also we can use this formula if we know the VF at the point when it returns to its starting position is 15, and then the VI was 15 plus, this was also plus negative 8 t. We could get the answer like that as well, because, and that's going to give us the whole time, because that's going to take into consideration the whole part, VI of 15 all the way till the VF of negative 15. And then there's like so many ways you could do this. You can actually also go in here, and then you know the change in y, if it's returning to its original position, the displacement displacement meaning change in height, is 0. So if we plug in 0 here into this formula, into formula number 3, plug in 0 there, we know the VI is 15, the t is what we want, plus half, negative 9,8 t squared. Okay, so t is the only unknown, easy to solve. 6 are like, I hope you understand all of that, pretty chill stuff. Okay, I'm not going to do that, you can do them. Calculate the distance between ball A and ball B when ball A is at its max height. Okay, so once we have the whole t, like once we have t from this question, whatever that answer was, if we divide that t by 2, we're going to get some other t, let's call it y seconds. Now this y seconds is the time it takes for ball A to reach the max height at the top. Okay, and that time, we also need to calculate a distance for that time. So let's calculate how far up ball A goes. Let's calculate A's maximum height, and we'll have the time y seconds that it takes to get to that maximum height. And then once we have A's maximum height, so we can use any formula to get A's maximum height. We could use change in y, except this time we want change in y. So VI is 15, so this is just to get A's max height, ball A's max height. 15, the time y, so that we know that y is the time it takes for it to get to its max height, because y is equal to this time answered in 3.2 over 2. Yeah, so plugging into this formula, half negative 9,8 t, well, y squared. and then that's going to give us A's max height, right? And then to get B's, like to get how far down B goes, because the question is asking calculate the distance between ball A and ball B when ball A is at its maximum height, right? So we know that it takes Y seconds for ball A to get to its max height, but now we need to calculate how far down B goes in that same time. Okay, and then we'll have this whole distance between ball A at its max height and then how far down B goes. If we add those up, we'll get the distance between the balls. So then this was for ball A to get its max height, and then to get ball B's, like how low down it goes, we'll just plug in again. Change in Y is equal to 0 in t seconds plus half negative 9,8. Well, Y seconds, because Y is how long A takes to get to its max height. Again, Y squared. So same formula, and then we'll call this X meters and Z meters. So that's how high ball A goes, and this is how low ball B goes. And then if we add them both up, X plus Z, we'll get some distance between the balls. Hope that makes sense. And then Tristan said you were struggling with with the graphs. Those are pretty easy. So we have to sketch a velocity time graph for ball A. We have to put in the initial velocity, the time it takes to get to its max height, and the time it takes to reach return to its starting point. Okay, so we're going to take upwards as positive always. Let's just not confuse anything. So velocity time graph. So V meters per second minus 1 and T. Okay, so we know that at time Y, we said that's the time it takes to reach its maximum height. And then whatever answer we put for 3.2, 3.2, calculate the time it takes. We just said that was T. Calculate the time it takes for ball A to return to a starting point, T, right? So just go plug in these values. So just mark off your X axis here. And we know initially it was projected at 15 meters per second, right? And then at time Y, at its maximum height, we know it was 0 meters per second, right? And then when it returns to its original position at time T, we knew that it was negative 15 meters per second. So remember what I said at the beginning. We project the ball up at an initial of V equals 15. It goes, it reaches its max height, and at its max height, we know V is equal to 0. And when it returns past its starting point on its way back down, its V is equal to negative 15, right? Because the time it takes to get to its max height and the time it takes to get from its max height back down to its original position is the same, right? And this is because there's a constant acceleration acting on it. So the acceleration is a negative 9,8, always. So this negative 9,8 meters per second squared is acting on this 15, decreasing its speed, and then it starts increasing its speed, but going downwards, right? So let's see what that looks like in a graph. So we know its initial was 15. Looks ugly, but it is what it is. And down here, let's just put in negative 15. So we know, now this whole part here of our graph is this whole part of his journey. Okay, what do you think is happening in this part of his journey? As we said, it starts off with 15 and it slows down all the way to 0. Okay, so it starts off at 15 and then it slows down all the way till 0. Now, why is that a straight line? It's because there's a constant acceleration, right? So if we had to measure the gradient of this line, it would be negative 9,8, because what is acceleration? Acceleration is change in V over change in T, which is change in Y over change in X in this case, okay? And then this part of the graph, because it's this part of its motion, and we said upwards was positive, this has to be a negative velocity, right? So it starts off at 0, and then acceleration kind of starts speeding it up, okay? its acceleration starts speeding it up, but downwards. So it goes from 0 to negative 15. Good. I hope this helps.